Hello, friends. Welcome to today's session. Today we will focus on the types of safety wall. First, we will just highlight what is the safety wall and why it's used. Safety wall is basically used to protect the equipments, pipelines like reactor, boiler, heat exchangers against excessive high pressure. And there are basically three types of safety relief walls. First is conventional type, the second one is bellow type, and third one is pilot operated type. So we will discuss one by one and how to select or which type of safety wall is required for as per our process suitability and the parameters. First is conventional type. So what is meant by the conventional type safety wall, or when to select the conventional type safety wall? Basically, common type of conventional safety wall is the spring-loaded pressure relief wall, and generally the safety walls are referred to the spring-loaded. You can see the spring here, loaded pressure relief walls. This pressure or spring stress is applied by this tightening of the screw, which is equivalent to our set point of safety wall, which is we called sometimes set pressure of safety wall. The load of spring is designed to press this disc against the inlet pressure, whatever wherever we have installed the safety walls, and that depends on the type of fluids, which fluids we are using against the safety wall to protect, like steam, whether it is gas or liquid. Okay, the basic one of the criteria is to select the conventional type safety wall is that it is selected when the back pressure is less than the 10% of the set pressure. So what is mean by the back pressure? Back pressure is the pressure acting during the pop-up of safety wall against it. Okay. So if suppose we have a set pressure of 10 bar gauge, then back pressure should be less than the 1 bar gauge, which is 10% of the 10 bar gauge is 1 bar gauge. So in that case, we can go with the conventional type safety walls. Okay. So another thing is this is the most common type and it is a spring loaded pressure relief wall. Okay. Then the load of spring, as I already discussed, the load of spring is designed to press this disc against the inlet pressure, and this is used for the applications where the fluid is clean, non-viscous, non-corrosive, and has no tendency to crystallize or polymerize. The user can use the or specify the conventional type safety wall, and it's is flexible as per applications. This can be used on a variety of fluids, whether it is compressible or non-compressible liquids, and making it suitable for the diverse process conditions. While limitations in a steam service for the conventional walls Well, versatile conventional PSVs are not ideal for steam service or the steam boiler or superheaters, and the main reason is its limitations to steam service is that the temperature sensitivity of spring. This spring can get contract or expand with respective change in the pressure, and the spring must be cooled to maintain its characteristics and stability against the set pressure. And it is challenging against the application for the steam uh, applications. Okay, and it has back pressure consideration, which I already discussed. Is the conventional safety walls are best suitable for the applications where the superimposed back pressure remains constant and does not exceed the 10% of the set pressure. Okay. The next type we will discuss is that balanced bellow type. What is mean by the balanced bellow type safety wall? This is the balanced bellow safety walls. Here the spring is used for the control the bellow against the set pressure. Okay, and the selection criteria for the bellow type safety wall is that the back pressure should be less than 50% of the set pressure of safety wall. Like we already discussed in conventional type 10% and in balanced bellow type it's less than 50%. Okay. Uh, the second thing is it has a bellow. If you can see the bellow is here that functions the cancelling the effect of variable superimposed back pressure, which acts against the relief pressure or set pressure of the balanced velotype walls, and it helps to back pressure compensation. Like its fundamental design of spring wall closely resembles that the conventional wall. Okay. However, a velo is integrated to compensate the fluctuating back pressure. As I already said, this is used for the fluctuating back pressure applications. This feature makes balanced velo walls is most suited for the applications where the back pressure conditions are unpredictable or fluctuating. Okay, when the back pressure is variable, I already discussed when to use the balanced bellow type safety wall. When the fluid is dirty, viscous, corrosive, and may crystallize or contain solid particles in suspension. Okay, that time we can use or go with the balanced bellow type safety wall, and it has the limitation due to the balanced bellow that the elastic constant of bellow prevents the lower set pressure. Like we cannot use this balanced bellow type safety walls where set point is less than the 1 bar gauge. Okay, and the balanced bellow type safety wall has improved safety that includes balanced bellow and bonnet venting, which is the bonnet venting safety by which enhances the safety by providing clear indication that bellow is failed or ruptured. Okay, it is versatile, which excels in application with the variable back pressure, which is the like less than 50% of the set pressure, And the third type we used is that pilot operated type. Okay, the pilot operated type safety wall looks like this. It has the pilot discharge pipe which is connected to the main outlet of the or the main connection. So this type of safety wall uses the fluid medium itself through pilot wall, and to apply the closing force on the safety wall disc which is located here. Okay, the pilot wall itself acts like a small safety wall, and there are two different types of pilot operated walls. One is the diaphragm type and another is the piston type. First, we will discuss when to select these pilot operated type walls. The selection of the pilot operated type walls is when the back pressure is the variable or greater than the 50% of the set pressure of safety walls, or it is close to the set pressure of the safety wall. We'll discuss the diaphragm type is typically only available for the low pressure applications, and it produces the proportional type action characteristics of relief valves used in the liquid system, and therefore the little use of such a systems or such a safety valves in a steam applications, and they will not considered in this steam application case. And another is the piston type safety valves or piston type pilot operated safety valves, which use the piston shaped like disc or diaphragm, which closing as a closing device, and the external piston wall. And the next is the application or it uses in the cryogenic applications, corrosive fluids for the high pressure applications, where the contamination of discharge fluid is not permitted. There we use the pilot operated type safety valves, and it is widely installed in the industries like oil and gas industry, chemicals and petrochemical plants, power generation, pharmaceuticals and food processing industries, aerospace and defense, and wherever the high pressure safety walls requirement is there, we can go simply ahead with the pilot operated type safety walls. The pilot wall system prevents the main walls from the opening prematurely. It prevents to opening of walls prior to the set point. It enhances the safety by ensuring wall only opens at the designated or the set pressure which is we have set during the designing or the manufacturing. This prevents the damage of system and reduces risk of accidents. Next, we just discuss about selection of seat MOC. We have listed EPDM type seat, MOC seat is used for the water applications, Wharton type MOC used for the high temperature gas applications, nitrile rubber is used for the air and oil applications, stainless steel seal material is used for the standard materials, or it is basically suitable for the steam or high temperature applications, and stellite is a wear resistance for the tough applications like in aerospace industry walls, or where the possibility of wear and tear happens. In such applications we can go ahead with the stellite as a material of construction for the seat material. This is just for now. In next lecture we will focus on how to prepare a instrument safety wall data sheets and its template. uh, Thank you for now. Bye bye.